So more of the Chapter 5 midpoint checkpoint, starting with number 10, which was very similar to number 9, finding each of the 6 of the trig functions. If we have the xy coordinate at that point and remember what that means, then for number 10, we are looking at the cosine of the angle being -3/5, the sine of the angle being -4/5. The tangent of my angle would be the ratio of those two, so -4/5 divided by -3/5, which becomes positive. And if you multiply by the reciprocals, think through that, the 5s cancel out. We end up really with just 4/3. And then with each of these, I can figure out my reciprocal function. So we started with the cosine. It's not quite lined up, but we'll look at secant theta then. Would be -5/3. And then sine and cosecant are reciprocals, so -5/4. Tangent and cotangent are reciprocals, so it would be 3/4 now that I have that other one simplified. So what this actually works to mean then, if you think adjacent, opposite, and hypotenuse, we have a side of 3 in my x distance and a length of 4 for the y. So this is actually a 3, 4, 5 triangle. It's a Pythagorean triple. And so I can see my opposite, adjacent, hypotenuse, the 4, 3, 5, if I think through that one. Numbers 11 and 12. Find the exact value if I know that this information is true. So for number 11, if I have a tangent that is negative, that happens up here in quadrant 2 and down here in quadrant 4 when sine and cosine are opposite in sign. For cosine to also be negative, that is either in quadrants 2 or in quadrant 3. And so for number 11, I am looking at, again, this 3, 4. And so it would be a triangle up here in quadrant 2. If I go left 3 and up 4, then I have again that 3, 4, 5 triangle. So my sine of the angle opposite over hypotenuse would be, my tangent is y over x. And so I have a height of 3, and I had to go left 4. So the sine of my angle is a positive 3/5 because it's positive in that quadrant. The cosine would be the -4/5. We already know what tangent is. That was given to us as -3/4. And so, again, cosecant, just reciprocate. Secant, -5/4. And the cotangent of the angle, would be -4/3 for number 11. So building that whole triangle to see what those parts are and just recognizing what quadrant this falls into. So for number 12, something very similar happens. I have a positive cosine. So I'm either in quadrants 1 or 4, but my sine is negative. So I actually would be here in quadrant 4. So the cosine is adjacent over hypotenuse. So my adjacent side would be 3 and my hypotenuse would be 7. And I don't actually then know what the y coordinate would be without doing Pythagorean theorem. So I have a 3 squared, we'll call it b squared equals 7 squared. So 9 and 49. And so b squared is 40, or b is the square root of 40, which, throw back to this review, 4 is a perfect square, but 10 is not. And those are two factors here. And so that actually becomes 2 square roots of 10 when I simplify there. So the sine of my angle would be, if this is 2 square roots of 10, 2 square roots of 10 over 7. But because it's in the 4th quadrant, that needs to be a -2 square roots of 10 over 7. The cosine is positive. We had that one. That was 3/7. And then the tangent, the ratio of those two, negative 2 square roots of 10 over 7 divided by 3 over 7, the 7's cancel, and I have negative 2 square roots of 10 over 3. The cosecant, if I look at my reciprocal here, negative 7 over 2 square roots of 10. When I multiply now by the square root of 10 over itself, I have negative 7 square roots of 10 in the numerator, and 2 gets multiplied by 10, or the square root of 100, to give me 20. The secant is much easier. It is simply 7/3. And my cotangent, the same thing happens when I have to reciprocate here. If I have negative 3 over 2 square roots of 10, whenever I rationalize, I get negative 3 square roots of 10 divided by 20. And now up above my negative 7 over 20, that doesn't simplify at all, and negative 3 divided by 20 doesn't simplify. I'm not allowed to touch what's underneath the radical, but I could work with that coefficient if it were possible in this case. It's just not. Last few SOHCAHTOA problems. So number 13. This time I don't care about all of my ratios. I just want to find the missing part. So if I look at 41 degrees, it's formed by the 60, which makes the 60 an adjacent side. And my hypotenuse isn't labeled. And then the 41 is opening up to the A, which is the opposite side. So don't care about the hypotenuse because it's not labeled. And then I am forced to use the tangent of 41 because that involves my opposite side and my adjacent side. To solve for A, I would multiply 60 by the tangent of 41. Degrees, making sure that my calculator is in degree mode. And we should get 52 centimeters when we round to the nearest whole number. 14, very similar. I have my hypotenuse labeled as C, so I'm looking at that guy. The 72 is formed by the 250 and the hypotenuse, so that makes that the adjacent. So it's my opposite that I don't care about. So if all I have is adjacent and hypotenuse, then I want the cosine of 72 degrees. That's equal to adjacent 250 divided by C. Now this time, if I multiply both sides by C, I have C times the cosine of 72. That doesn't solve it for me. This is the situation where we see division. So my 250 degrees is getting divided by the cosine of 72, and I end up with an answer here to the nearest whole number of 809 meters for number 14. So still SOHCAHTOA, it's just that I'm forced into using one of them based on the parts that are labeled, basically. So one is known, one is unknown. For number 15, the cosine of the angle is 1/6, and the angle is acute, and I'm trying to find the cotangent. So if I have an acute angle in this again, I think of my hypotenuse then must be my 6, and this is not well drawn to scale. Maybe make that a little taller. My 6, I would have a 1 right here. So my opposite side I don't know, and the cotangent of pi over 2 minus theta would be equal to the tangent of the angle. And so that relationship I had there with complementary angles, if I could find the sine, then sine divided by cosine is tangent, or if I could use this to find my missing side, we can call that B, then I can do opposite over adjacent to find the tangent. So 1 squared plus B squared is 6 squared. 1 plus B squared would be 36. So if I subtract 1, B squared is 35. So B, or the height there, or the opposite side, is the square root of 35. So the tangent of that angle would be opposite over adjacent, or the square root of 35 over 1, which really is just the square root of 35. So we have not done anything like that. That would be more like a challenge problem, as that has a lot of review information in it, using the Pythagorean theorem, recognizing that cosine is adjacent over hypotenuse, and then recognizing also those complementary angles to know how that plays in to help us get to that answer directly. This next set of problems, though, find the exact value. Do not use a calculator. This is where we need to simply look at the unit circle. So for number 16, a little bit of work because we have the tangent at 30 degrees. So y divided by x would be 1/2 divided by the square root of 3 over 2. And this, again, the work to rationalize the denominator, leaves you with the square root of 3 over 3 for that answer. Number 17, the cotangent of 120 would be my x divided by y instead of y divided by x, just the reciprocal of that. So if I think of the cotangent, it actually works out to be the same. I have -1/2 and then the square root of 3 over 2. So same work rationalizing. I'm just going to end up with negative square roots of 3 divided by 3. The cosine at 240 degrees is a little bit easier. That's just right on my circle at -1/2. And then the secant is 1 over the cosine at 11 pi over 6. And at 11 pi over 6, I'm looking at the square root of 3 over 2. So I would actually have, instead of the square root of 3 over 2, I would have 2 over the square root of 3. That's what happens when I take and reciprocate that. So again, rationalizing, I end up with 2 square roots of 3 over 3 for that one. Sine squared of an angle plus cosine squared of an angle, we did not spend a whole lot of time addressing. That is simply 1. For number 21, the sine at -2 pi over 3, -2 pi over 3 is going to be the same. Let's try this again. -2 pi over 3 is going to be the same as 4 pi over 3. And so that is negative square roots of 3 over 2. Cosecant of 22 pi over 3. I just have to recognize that as the reciprocal of the sine. And working backwards from 22 pi over 3, again, 22 pi over 3, subtract off 6 pi over 3 as many times as I need to. So 16 pi over 3, and then 10 pi over 3, and then one more time. So I'm actually looking at 4 pi over 3. So if you look at the sine at 4 pi over 3 and take 1 over the sine, you have 2 over the square root of 3. These are the same numbers over and over again. If we rationalize that, it becomes -2 square roots of 3 over 3. And then the cosine at 495 degrees, I have to do the same thing. If I subtract off 360 degrees, that really is equivalent to 135. So looking into my second quadrant there, that's negative square roots of 2 divided by 2. These next couple, a lot of the same thing happened. Negative 17 pi over 6, I have to add 12 pi over 6 a few times. So negative 17 pi over 6, if I add 12 pi over 6, that only brings me to -5, so I have to do it again. And that brings me to 7 pi over 6. So y over x, or sine over cosine, would end up being 1/2 divided by the square root of 3 over 2. And so that 1 over the square root of 3, again, rationalizes to the square root of 3 over 3. 25, we've not covered anything like that. And 26 is another kind of challenge problem, recognizing what happens when we look full circle at those values.